Well, I've connected the MIDI cable to the Arduino over here, and the optocoupler is on the breadboard right now, and there's some diodes and resistors to make sure that the MIDI signal is converted correctly to the Arduino. So it's set up to receive the MIDI signal on input 0 on the Arduino. Don't mind the stuff over here, that's still from my last project that I still have to finish. But I only use this side of the breadboard right now. I found an Arduino sketch online, so it's set to blink the LED on the Arduino when there's MIDI tempo present. So let's load it up. Got the familiar noise. Now the LED only flashes when you first send the MIDI start or the MIDI continue message. I have to start it first and then send the MIDI tempo. And as you can see, the LED on the Arduino flashes according to the tempo. When I increase the tempo, you can see the LED flashing accordingly. Maybe I will change it later so it only reacts to MIDI tempo and not to the MIDI start or MIDI continue message. But for now it works. Right now I'm gonna add the relay to the Arduino to pin 13. So the relay doesn't really quite fit the breadboard, but I found a nice workaround. And as you can hear by the clicking, the relay does its job. So now I've added a TRS jack to the relay switch, but only the tip is connected, so the ring is free. It's the green wire over here. And the TRS jack is connected to the footswitch input on the RC3. So now when we send MIDI tempo, the relay will open up the circuit for the stop switch, which is the tip of the TRS cable, and that will start the tap tempo sequence. Alright, here we go. And that seems to work. Let's try another tempo, like 76 BPM. And I have to remember that I stop the tempo, because otherwise it will still continue to open up the circuit and go back to the tap tempo again. Alright, it all seems to work fine. So now I've connected the ring of the jack to the relay, and in this setup I can test the memory shift function. Well, you might know when you have to shift the memory, you can press the foot switch once and then it will shift up. But when you press the foot switch long enough, it will shift down eventually. But I want to know what the rate is. So how long do you have to press the foot switch in order for it to go down, and in what rate does it go down after that? So I will upload a little program, and in this program I will open up the circuit for 1 second, then close it, and wait 5 seconds for it to open it again, but this time for 2 seconds. Close it again, there's a pause of 5 seconds again, then it will open up for 3 seconds, then a 5 second pause, and a 4 second opening. And in that way I can find out in what rate does the memory shift when you close the circuit. So I'm going to start off on memory slot number 20, and we will see what will happen when we upload this program. That was 1 second, and you can see it shift up 1. That was 2 seconds, and now it's down again, back to 20. This is 3 seconds, and it went from 20 to 17. That was 4 seconds, it went from 17 to 12. So you start with 2 seconds of button pressing before it goes down, and then for every half a second it goes down 1 step further. So 2 seconds it's 1 step, every half seconds after that there's another step. So you can go down to this formula where it's 500 times the number you want to shift down plus 1500 milliseconds, because Arduino always counts in milliseconds. This is the stripboard design that I made for this project. The foot switches are directly connected from digital inputs 2, 4, 7 and 8 to ground. An internal pull-up resistor is added in the Arduino code. The LEDs are on pin 3, 5, 6 and 9. These pins have pulse width modulation for direct dimming of the LEDs. The relays are connected to analog pins 0 and 1, but these are set up as digital outputs in the Arduino code. The digipot for expression out is connected to pins 10, 11 and 13, and the expression input is on analog pin 5. By the way, people who worked with Arduino before know that digital pins 8 to 13 and the other pins after 13 are a little offset, and it won't fit the standard stripboard if you want to connect the whole circuit as an Arduino shield. I've placed these connections on a separate little board and connected them via wires. MIDI out is on digital pin 1. This is usually the Arduino's transmit pin anyway. MIDI in is connected via an optocoupler to digital pin 0. But since this pin is also wired to Arduino's USB, it causes trouble when you want to upload your program. To solve this, I've added a jumper instead of the purple wire between pin 0 and the optocoupler. I remove the jumper when I upload the program and place it back when I run the program. Alright, let me walk you through the code. So this is the final code that I've used. First you include the MIDI protocol. These are the pins for the buttons. You can see that I've started them with 0. It's this one over here. This one is called number 1, number 2 and number 3. So yeah, I'm going to start off with 0, just like a real programmer. The same thing with the LEDs. Like maybe I mentioned this before, but I ran out of digital pins. So the tip of the TRS jack, that's in the middle right here, the tip is connected to analog 0 and the ring is to analog 1. There's also the expression input and the expression output, but those aren't used right now in this program. There's this the button state that I'll come back to in a minute. Or the receive pin for the MIDI that's on digital pin 0. These are some counters that I'll come back in a minute, and they work together with this thing. Some other variables for the programs. The MIDI messages that it will react to. Okay. In the setup, I start with the baud rate of 31,250, which is the rate that MIDI also works on, and define that the TRS jack is an output, so not an analog input, but the Arduino also works as a digital output. Those pins, those analog pins. The buttons are an input, and I switched on the internal pull-up resistor in the Arduino itself with this code. The LEDs. This is the little startup sequence when you first plug the pedal into the power. So the LEDs will flash. Let me show it again. So the LEDs will flash in a little sequence. All right, now the loop part. When you start the pedal, there's a counter starting right away, which counts the milliseconds, and it will read what the buttons do every time. This is the first part is here. It'll do the button number 2, the stop button. Basically, it checks if the MIDI program is running, the tap tempo program. There's this one. Come back to that in a minute. And if it doesn't, and the button is pressed, and I used this bit so that removes the jitter when you press it. So there's always a little jitter when you toggle a switch, and that could mess up the whole program. So this part right here makes sure that the jitter is removed from the button pressing. So when the button is down for 50 milliseconds, so that's really short, only then it counts if the pedal is actually on. Then it will write the tip of the TRS jack when you press the button. So as long as you hold it, the tip to sleeve will open via the relay. Yeah, when you step off the button, it will close the circuit again. And then it will reset the button values for the jitter removing. So this is the program for the MIDI tempo. Basically, it checks if there's a MIDI clock present, and if the program isn't running, and if the button is down, that'll give the signal that there's the MIDI present, and that you can start converting it to the tap tempo. So when you press the button now, it'll do nothing because there's no MIDI tempo, MIDI clock sent to the pedal. This part of the program makes sure that if there's MIDI data coming into the pedal, that it also sends it back out. So MIDI comes in and MIDI sends it back out to the other MIDI jack. And if there's MIDI clock present, that'll turn on the sync. And the sync program will flash the LED 0 over here. And this little part will reset it back. And this is the last part. So if the tap tempo program is executed, it'll tap it for 5 times, and then it'll stop the tapping. So it taps it for 5 times and then stops it again. So let me show you. I'll turn the volume down on the RC3, and I hope you can hear it when I send. You can hear it clicking for 5 times. This is the program that will execute a memory shift when you press this button. Basically what it does is it checks if there's a short press under 2 seconds, that'll go up 1 memory. So that's always 1. And if you hold it for more than 2 seconds, it'll start pulsing for every half a second after that. So after 2 seconds, it'll start shifting up in a higher rate. So first 1, and now every half a second. This is the program that will stop the shifting down when you press this button. So it works together with this part. Basically what it does is it counts the number of presses you put into it, and that'll open up the ring to sleeve circuit, so the memory shifts down. So it counts the number of presses, so 1, 2, 3, 4, 5. And it should go down to 23. There we go. So that's what this does, but you can also hold it, or you can combine the two. So maybe if I think, oh, I'm gonna shift the memory down, and I think, well, that took way too long, so I'm just gonna hold it right now, and it'll still go shifting down. And will stop shifting if you release the button. So that's what this does. So this was the loop function in the Arduino, and here are the other programs. So basically, the sync program is if there's MIDI tempo present, it'll flash the LED 0, and it'll invert that when you execute the program. So now it flashes along the beats. When you press it, it reverses that. That's what that stuff does. And these two little programs over here to shift it up and shift it down in memory. So yeah, that's basically it.